key things like RAG, fine-tuning, agentic AI. These are all very trendy terms these days.
Yeah, for sure. So once a model has been selected, the next step for an AI engineer is to then figure out, okay, how are we going to optimize applying this model to the problem at hand? And of course, then the world breaks in two. You've got the kinds of things you can do at training time and the kinds of things you can do at inference time. And training optimization, that's where we began. That's all that people did maybe a year and a half ago. We were all fine-tuning models. We're using LoRa, QLoRa to fine-tune an open source model, or you can also fine-tune a closed source model as well. But increasingly, in the last year and a half, people have been using more and more inference time techniques to better optimize your model for the problem at hand. And I think that the OG of this is probably multi-shot prompting, which we were all doing way back, giving a bunch of examples, providing that to the model and say, hey, here's a few examples, and now here's the new question you're being asked. Then along came RAG, where you take the question and you then look up in your database, okay, do I have information that I could provide the model that's going to help it answer this question? And RAG has lots of fancy stuff. There's lots of techniques you can use to get better and better at selecting the right information that's going to be most likely to be useful to the model, to bias it towards giving a high accuracy result. And RAG comes in lots of flavors. There's a hierarchical RAG where you make multiple queries to your vector store to get bigger, broader documents, and then more fine-tuned parts of it.
That's news to me. Cool.
Yeah. So, for example, let's say you've got an airline has a chatbot, and someone asks the question of, I'm going to Paris this Christmas. What could I do in Paris over the Christmas time? Maybe first of all, there would be a RAG query just to retrieve all of the information about travel to Paris. Back would come a lot of information. And then a second query would select out holiday season activities so that it could be just a little bit more precise in the context that's provided.
So the second one is doing RAG on the first round of documents that was brought back. I got you.
Exactly.
That's
cool. And there's actually another kind, which is somewhat similar to that, which is called query conditioned RAG, which is a bit similar to something that we do at Nebula, which is where you take the original query from the user, like I want to go to Paris and do holiday related things, and you pass that to an LLM, and you have the LLM rewrite that in the form of a query that's going to be most applicable for RAG to query against your vector data store.
Yes.
And so that gives you that 2 rounds before you look up in the data store. Again, increases the accuracy of the context that you're providing the model.
Yes, very cool. That has been powerful for us at Nebula for sure. And I think one thing that we may not have mentioned is that RAG stands for Retrieval Augmented Generation.
Right.
And that meaning that it's a generative AI, but you're augmenting your responses by retrieving relevant documents, relevant information from potentially a vast, vast store of billions and billions of documents you could search over efficiently.
For sure. And of course, as you say, usually the way you're doing that is you're taking the question and you're passing it through an encoder LLM that's able to turn that question, that block of text, into a series of numbers. And you can think of those series of numbers as representing a sort of a point in multidimensional space, which reflects in some way the meaning of that text. And if you've also taken all of your millions of documents and you've also found little vectors associated with each one, then the idea behind RAG is you just find which of these documents are closest to this question that you're asking. And you take those documents and you just shove them in the prompt. And you say to the LLM, hey, let me provide you with some context that might help you in answering this question. And that's the idea.
Nice, yeah. And then fine-tuning and agentic AI, I think, are the remainder. Or do you want to dig into those later?
No, for sure. All topics we could spend an entire podcast talking about any of them, of course. And they're fascinating. Agentic AI is, of course, all the rage at the moment. This is such a hot topic. And agentic AI, it's a technique. There are some hallmark situations when you think, okay, agentic is going to work for me here. One of them is where you have a complex problem and it's clear that it's going to make sense to break that down into a series of smaller steps that are each well-defined and that together will solve the bigger problem. That, of course, sounds like agentic AI. Another obvious case is when you want to be able to make use of tools, which, for example, is supposing you're writing a model which is going to generate some code. Potentially, you want to be able to call a tool that will execute that code and then inform the LLM whether it worked or not, and it can use the tool to iterate on that solution. The third situation where you might use agentic AI is probably the hardest one to explain. And it's the case where you're trying to solve a problem where the LLM needs to sort of exist beyond the construct of a chat with a user. It's got a sort of longer lifespan than that. It's got some sort of autonomous existence. And maybe to make it concrete, an example might be, again, if we think of this airline that's having this conversation with a user that says, I'd like to go to Paris for the holidays, what can I do? They have that conversation. Maybe a few days later, the LLM detects that the ticket price to Paris has come down by $100, and it proactively text messages that same user and says, I've noticed the price of the ticket has come down. Are you now interested in your Christmas holiday in Paris? And so from that perspective, it's kind of got this existence that goes beyond this one chat conversation.
Mm-hmm.
And that sounds like, okay, that's an agentic AI solution right there.
Yeah, I think the key difference is agentic AI allows you to be proactive as opposed to reactive. So if you're using an LLM in a non-agentic setting, like going to ChatGPT and typing in a query, it is reacting to your query. Exactly as you said perfectly there with that example of an agentic system noticing, proactively scraping the web to look for deals, noticing that the price has gone down and notifying you.
That's a really nice way of explaining it, for sure. And then there's one small recent delta on agentic AI that's very similar, which is the emergence of reasoning frameworks, which is perhaps just a way of applying agentic AI. But these are frameworks which are able to make multiple calls, usually to the same LLM, to guide it through the process of reasoning, very much like the way we see O1 Preview reasons its way through a particular thread. And so reasoning frameworks is another technique that AI engineers can use to try and get more from their models.